I'm doing my master's thesis under the supervision of Coetzee and Martin Hill. Salvinia molesta has been a target for biological control here in South Africa and of course throughout its exotic range. It has been brought under control by the weevil Cyrtobagous salviniae. Looking at the pictures we have before our application of the weevil, you know that we can get as much as 100% coverage of the water body, but after the introduction of our weevil, we get close to pristine site. Then, as to the motivation of this study, we find that after initial control using the biological agent, we at times experience reinvasion of that site. Then this is especially true in areas where Salvinia crosses in understory species, especially where the water is shallow and is in a shaded spot. Going on to the major objectives of this study, it is first and foremost we want to test the effects of shade on the plant nutritive qualities, which may subsequently affect the biological control. And it will also be important to look into the impacts of the shade microclimate that may be created by the shade on the development of the weevils and also subsequently on the success of our biological control. Then this study shall be two-pronged. We've got a field study which has already been set up and also a greenhouse study also which has been set up. Looking into the field, we are, as for the field, we have got two sites, a shaded site and a light site. In both of these sites, we have set up quadrats, 1 square meter each. There are 12 quadrats for the shade and open site. And then in half of these quadrats, we have manipulated the conditions by applying nutrients. We have done nutrient enrichment in these quadrats. Then in the other half of the quadrats for both the shade and light, we left them as they were. Then in all of the quadrats, we released adult weevils at a rate of 100 adults per square meter. Then looking into the greenhouse control study, we've got 3 treatments in there, 80% shade, 40% shade, and a light treatment. Then we also have a set of tabs outside the greenhouse to control for the light, since the greenhouse material may intercept and reflect some of the light. In each of these treatments, we've got 4 sub-treatments again, where the plants are subjected to the following treatments. There is weevil inoculation plus fertilizer additions. Then we've got a treatment where there is only weevils, another one with nutrient enrichment only, and a last one which is the control with again manipulations. So these are just the pictures of the setup in the greenhouse, and the second one, the setup outside the greenhouse. Then the parameters of interest for this whole study, we are going to look into the fresh and dry biomass of the plants. Then we are going to look into the chlorophyll measures, and these two shall be done at 2-week intervals for the field and control study. Then we are going to look into the total plant nitrogen as well as the water nitrogen content. For the plant nitrogen analysis, we are going to use the stable isotope analysis, and then for these two again, we are going to record them every month. Then plant damage and lift up in rates shall also be recorded every 2 weeks. Then weevil population growth at 40-day intervals owing to the relatively long developmental cycle for the weevils. Shade mapping and solar lux recorded every 2 weeks. Air and water temperatures at 1 hour intervals using temperature data locals. And in conclusion, I'd like to say it will be interesting to find out how and why this weed has successfully evaded our efforts to control it using the weevil Cyrtobagous salviniae, especially in areas where it grows under the shade, notwithstanding the fact that this weevil has been effective in controlling this weed for the greater part. I thank you.